Welcome to part 3 of the instructive series, and today we're going to be going over Arduinos. So I'm not sure if many of you would know or not know what an Arduino is. An Arduino is like a very small computer that you're able to upload code to, and it will, as long as it has power, will run the same process, whatever you decide you want it to do, over and over again. So in the case I'm showing you here, it's being used to count how many rocks are placed on a pressure sensor, and it's sending that data to the computer, and then this project used a Python script to convert that into music. So again, same as last time, I'm not here to teach Arduino. There's plenty of resources online. YouTube would be a great place. Arduinos are very common, so there's a widespread community posting on forums online, looking for help, how to do this, how to do that as well. Again, I don't recommend using AI, but if necessary, AI can help with Arduino. If you know C, Arduino uses its own language, but it's based on C, so, they are very useful for combining hardware and software, especially hooking them up to sensors and getting real world readings of what's going on and using that data to do something. So this is kind of the alternative to lesson 1. In lesson 1, we were showing how to use pre-existing data, where to find it, and what it might be used for. Is this is live data, with something being done as the data is being read. So, sorry, this line here, this is an old version. It uses another board called a WAV trigger. That's irrelevant to most of you, unless you specifically want to use that kind of board. So don't be worrying about what it says. What these do is declare different types of variables. So integers, and this creates an array of integers. What that's doing is declaring the pins that are hooked up to the other board. You would need to declare pins that are hooked up to to sensors and all that. Longs are another type of number. It's kind of, if you want decimal places, more storage. Integers can't have decimal places. Bools are true or false. They can only have one meaning. And integers obviously are numbers, but can't have decimal places. Capacitive sensor is a library. As you can see, similar to Python up here, you include libraries. Arduino has a whole range of libraries available on their website, plus there's some ones, open source ones made by other people. So this specific one, what it does is to make the pressure sensor, it's connected to 2 different tinfoil sheets with a bit of separation in between them. When a rock is placed on the top tinfoil sheet, the distance between them closes, and the Arduino is measuring the capacitance between those 2 sheets. So the capacitance increases as the distance closes, so it's able to tell when there's a change in capacitance, as in when there's a rock taken on or off. So that's what this is. This line here is setting up 2 pins connected to the 2 tinfoil sheets. So Arduino always has a setup function, which just runs once at the start. It's used to, so here I'm setting the pins to inputs. Initializing certain values, stuff like that. Serial begins the serial connection between the Arduino and the computer and allows data to be written across. And then loop is the main Arduino function. So this will run repeatedly as long as your Arduino has power. When power turns on, setup will run once, and then loop will run continuously until power is gone. So this is where you want to do the main part of your code. So what this is doing is talking about if the difference between the past value of capacitance and the current value of capacitance, that distance changes by more than 10,000. It's an arbitrary value. And it hasn't changed within the last I don't know, 50 milliseconds, whatever it is, then add to the count of rocks. Or, sorry, that's another if statement to determine whether the capacitance is higher or lower to know if a rock was added or taken off. And then what this is doing is serial printing the count in onto the computer, where the computer is then reading it into a Python file. So once I upload this, what you do is you write a code here. You have to have an Arduino plugged in, and you can select which port it's plugged into. And you upload it to the Arduino. Once I do that, I can close the Arduino IDE programming, move over to Python, and run that code. And that's able to access the data being sent by the Arduino and use it for its own purpose. Now, this is not compatible with Colab. Colab can't access your serial ports. So if you did want to use this with Python, you would have to have Python installed on your computer. And then there's an arbitrary delay down here. Now, let's say if you wanted to have another function, we could have void atom. You can name it whatever you want. Start it here. There's a function. We could have it print. Sorry, Arduino. I'll get confused between my languages. Serial print I, and then that could be called here. And now, so, you know, if you had a function that you only wanted to run sometimes, let's say if there was a change in the rocks, you could have an if statement. If there's a change, run atom. So you don't only need to limit yourself to setup and loop. That's probably all I'm going to say for the Arduino coding side of things. You'd also need to learn some wiring, some electronics. If you wanted to build a circuit, most readings will involve circuits. You know, you can't just hook them up and hope sensors. You'd need to do some research online how to do that. But this is how you use the IDE, and like I said, there is so many resources online that are available to you. And if you have a background in coding, Arduino is quite simple to learn. And even if you're running into problems, like I said, there's always resources online to help. So thank you. That's part 3 of this instructive series, and I look forward to working with this.